Okay, after all of this, we should now finally be able to answer the Boston question. So you may have missed it. I came up here on another part of the practice where once we had talked about isolating the trig, we knew we were able to do that, and so I subtracted the 12 from both sides, divided by the 3, and so we get negative 1/2 equals sine of all this mess. So let's go ahead and, now that we recognize instead of it just being an x in there, it's a sign of some significant expression, we're going to go ahead and substitute it out. We're going to say that 2 pi over 365 times x minus 79 is equal to r, some other angle r. And so we've got negative 1/2 equals the sine of r. Well, that occurs, let's see, angles that have sine equal to negative 1/2, that is, so r would equal 7 pi over 6 plus 2 pi n. And the other one is r equals 11 pi over 6 plus 2 pi n. And then, I don't know, I'm a little stumped here. Let's go with 2 pi, I'm substituting back in now, 2 pi over 365 times x minus 79. I'm going to ignore the 2 pi plus 2 pi n for now. I don't know if I can or not, but I can't see how to do the rest of it from here if I don't do that. So let's check it out. Kind of learning together on this one. Alright, so, sorry, let's go ahead and multiply by the reciprocal, because we're trying to get x by itself now, so we're going to multiply by the reciprocal, so we've got x minus 79 equals 7 pi over 6 times 365 over 2 pi. So at least the pi's cancel. That leaves us with whatever 7 times 365 is. 7 times 365. And let's divide that by 12. So we get x minus 79 equals 213. So x would equal 292. So day 292 of the year would have 10.5 hours of daylight. Let's see if this answer yields anything for us. So same thing, let's replace the r with 2 pi over 365 times x minus 79, 7 pi over 6. I'm sorry, this time it's 11 pi over 6. And so we're going to go to the same thing, multiply by the reciprocal. So we've got 11 pi over 6 times 365 over 2 pi. Cancel, cancel. So this time we're going to do 365 times 11 and divide that by 12. And we get 334 plus 79 degrees. So we got 414-ish. So day 414, but that's after, that's several days into the new year. And so what we'd actually do here is, I'm going to say, well, what if I took away 365 days? That would put us around the same amount of daylight a year earlier. And so I'm going to do 414 minus 365, and I get day 49. So x equals day 49. So 49 days after January 1st, and 292 days after January 1st would be the two times when Boston has 10.5 hours of daylight. That makes sense to me. 49 hours after January 1st, or 49 days after January 1st, that'd be somewhere in February, probably like February 20th-ish, around there. And then this one would be sometime, let's see, probably in November, maybe even in October. I'm just kind of doing quick estimates in my head here. You still have another 73 days left, so actually it probably is in October. And so it seems reasonable we'd have about 10.5 hours of daylight. I'd say that if the sun gets up at like 6, goes down at 5, 4:30, somewhere around there. So these seem reasonable to me. Hopefully they seem reasonable to you. I know I kind of just, we figured it out together as we went. I wasn't exactly sure where I was going, but we got there, and let me know if you have any questions. Okay, so I just went ahead and graphed the two equations. I graphed our initial equation. I paused the video recording and